Hello everyone, welcome back to the Atharva Academy. Myself Chinmay Daduk. In previous video, we have discussed that what is Mohr circle and we have also discussed some examples on Mohr circle. Now in this video, we are going to understand normal and shear strain in the case of combined loading condition. In this video, I will tell you that how to remember equation of normal and shear strain. And we will also discuss that what is strain Rosette and what is stress tensor. Fine. So first of all, we are going to start with normal and shear strain. We have already remembered the equation of normal and shear stress that is given here. Now if you have remembered this equation of stresses, then it is easy to remember the equation of strain. Fine. Now to remember these equations, you have to take normal stress as normal strain and shear stress as shear strain by 2. Means here in all this equation you have to put sigma is equal to epsilon and tau is equal to gamma by 2. For example, if you want to find equation of normal strain at any plane, then you have to put sigma is equal to epsilon here and tau is equal to gamma by 2. So here this equation will become this. Here sigma n is epsilon n, this sigma x plus sigma y by 2 is epsilon x plus epsilon y by 2, this sigma x minus sigma y by 2 is epsilon x minus epsilon y by 2, and here this tau xy is gamma xy by 2. And similarly, if you will follow this method, then you will be able to remember the equation of shear strain at any plane, maximum and minimum principal strain, maximum shear strain, plane of maximum principal strain and plane of maximum shear strain. Here you can pause the video and you can understand that how to remember these formulas, and you can also remember these formulas from the notes of strength of material. Fine. And once you will remember these formulas, you will be able to find normal strain and shear strain at any plane. You will be able to find maximum and minimum principal strain from here. You will be able to find maximum shear strain from here. And you can also find plane of maximum principal strain and plane of maximum shear strain from these two equations. Fine. Now we are going to understand strain Rosette. So first of all, we have to understand that why we need to use strain Rosette. See, in any member, if we apply different loading condition like this or this type of loading condition, then there is stress produced in the body. And we know that how to find value of stress theoretically. Fine. But if we want to find value of stress in the body practically, so we cannot find value of stress directly in the body. To find value of stress practically in the body, first of all we have to find normal strain in x direction, normal strain in y direction and shear strain gamma xy. And you can find value of strain by using strain gauge. Here this strain gauge is a device to measure strain in any particular direction. Means one strain gauge is used to find out one value of strain. So to find out these three value of strains, we require 3 strain gauge. And we put these 3 strain gauges on this body in any particular arrangement. And then we apply different loading condition on the body. And by using these 3 strain gauges, we can find out value of epsilon x, epsilon y and gamma xy. And once we have these values, we can find out epsilon 1 and epsilon 2. That is the value of maximum principal strain and minimum principal strain. And if we have value of epsilon 1 and epsilon 2, then we can find out value of sigma 1 and sigma 2. That is maximum value of principal stress and minimum value of principal stress. So ultimately we can find out value of stress in this body practically. Fine. And here we find value of maximum principal stress and minimum principal stress because for brittle material this maximum principal stress is responsible for the fracture of the body. Fine. So ultimately our aim is to find sigma 1. And we also know the equation that how to find sigma 1 and sigma 2 from these two values. We know that epsilon 1 is equal to sigma 1 by E minus mu sigma 2 by E. And we also know that epsilon 2 is equal to sigma 2 by E minus mu into sigma 1 by E. Right? This equation we have discussed in the chapter 2. So here we have value of epsilon 1 and epsilon 2, and we have also value of Young modulus and Poisson's ratio. So here we have two unknown, that is sigma 1 and sigma 2, and we have two equations. So by solving these two equations we can find out value of sigma 1 and sigma 2. Basically this topic is not important as per the GATE point of view, but it is in the syllabus, so here we are going to discuss it. Fine. So I hope that you understand why we are using this strain Rosette to find out strain. Because we directly cannot find value of stress practically in the body. So first of all we have to find out value of strain, and then we have to convert this value of strain in the value of stress. Fine. So here we can say that strain Rosette is an arrangement of two or more strain gauges that are positioned closely to measure strain along different direction of the component. Fine. And here first of all we find value of epsilon x, epsilon y and gamma xy from given values of epsilon a, epsilon b and epsilon c. And here these values are value of strain that is measured from strain gauges, and hence we can find principal stress in component. Fine. Now here we are going to use this equation to find out value of epsilon x, epsilon y and gamma x, y. So you have to remember this equation, and I have told you that how to remember this equation, right? Now in this equation, this epsilon n is value of normal strain on any plane which is at angle of theta. Here this epsilon x is normal strain in x direction, this epsilon y is normal strain in y direction, and this gamma xy is shear strain in body. Fine. Now we are going to discuss different types of strain Rosette. Now there are three types of strain Rosette. First is rectangular strain Rosette, second is delta strain Rosette, and third is star strain Rosette. So first of all we are going to discuss rectangular strain Rosette. And first of all we are going to discuss rectangular strain Rosette. Now here you can see that it is rectangular strain Rosette. It is the arrangement of three strain gauges, strain gauge A, strain gauge B and strain gauge C, arranged in particular order. Here the strain gauge A is on the x direction, the strain gauge B is at the angle of 45 to this axis, and the strain gauge C is arranged in the y direction. And this strain gauge is arranged in the body on which we apply loading. And once you apply load in the body, you will be able to read value of strain in this three direction. So you will have value of epsilon A, epsilon B and epsilon C. Now here we have to take this theta from x-axis, and in this direction means in anti-clockwise direction. So here for strain gauge A value of theta will be 0, for strain gauge B value of theta is 45 degree, and for strain gauge C value of theta is 90 degree. Fine. So from here we can see that at theta is equal to 0, value of strain, that is epsilon n, is equal to epsilon A, right? So first of all you have to put theta is equal to 0 in this equation and epsilon n is equal to epsilon A here. So you will get one equation that epsilon A is equal to epsilon x. Fine, because here if you will put theta is equal to 0, then this term will be 0, right? And here if you will put theta is equal to 0, then this cos 2 theta will be 1. So finally you will have these two terms, and here this epsilon y will be cancelled. So you will have epsilon a is equal to epsilon x. Fine, so you have this one equation. Now if you will put theta is equal to 45 degree, now we know that at 45 degree angle value of epsilon n is epsilon b. So we can write that at theta is equal to 45 degree epsilon n is equal to epsilon b. So here you have to put epsilon n is equal to epsilon b and theta is equal to 45 degree. Then you will get another equation, and that is epsilon b is equal to epsilon x plus epsilon y divided by 2 plus gamma xy by 2. So here we have this second equation, and we know that at angle of theta is equal to 90 degree, value of epsilon n is equal to value of epsilon c. So here we can write that at theta is equal to 90 degree, epsilon n is equal to epsilon c. So if you will put these two values in this equation, then you will get epsilon c is equal to epsilon y. Fine, so here we have this third equation. Now if you will get question from this topic, then you will have value of epsilon a, epsilon b and epsilon c. And by using these three equations, you can find out value of epsilon x, epsilon y and gamma x y. Fine. And generally in the question, you have to find out value of these three strains. Fine. And you can also find value of epsilon 1 and epsilon 2 from these three values. So I hope that you understand how to solve question from this topic, that is strain Rosette. Now we will discuss delta strain Rosette. Now we will discuss delta strain Rosette. In this strain Rosette, this three strain gauges is arranged in delta shape. Here this angle is 60 and this angle is also 60. Now in this case we will also use same equation. For strain gauge A, value of theta is 0. For strain gauge B, value of theta from x-axis is 60 degree. So for strain gauge B, value of theta is 60 degree. And for strain gauge C, what will be the value of theta? To find out value of theta for strain gauge C, you have to take angle from x-axis in anti-clockwise direction. Means you have to take this theta. And here this theta is 60 degree, so this theta will be 120 degree. Right? So for strain gauge C, value of theta is 120 degree. Now we can say that at theta is equal to 0, epsilon n is equal to epsilon a. So here if you will put theta is equal to 0 in this equation and epsilon n is equal to epsilon a, then you will get epsilon a is equal to epsilon x. So you will have this one equation. Now we know that at angle of theta is equal to 60 degree, we have epsilon n is equal to epsilon b. Fine. So if you will put epsilon n is equal to epsilon b and theta is equal to 60 in this equation, then you will get epsilon b is equal to epsilon x plus 3 epsilon y divided by 4 plus gamma xy by 4. And here you will have second equation. And we also know that at angle of theta is equal to 120 degree, epsilon n is epsilon c. Here epsilon n is equal to epsilon c. So if you will put theta is equal to 120 degree here and epsilon n is equal to epsilon c here, then you will get this third equation, that is epsilon c is equal to epsilon x plus 3 epsilon y by 4 minus gamma xy by 4. And here we have this third equation. So now we have three equations and three unknowns, that is epsilon x, epsilon y and gamma xy. And here you will have value of epsilon a, epsilon b and epsilon c. So you will be able to find these three values. Hence you will be able to find epsilon 1 and epsilon 2, that is maximum value of principal strain and minimum value of principal strain. Fine. And now we will have third type of strain rosette, that is star strain rosette. In star strain rosette, we have arrangement of strain gauges as shown in this figure. Here the strain gauge A is on the x-axis, this strain gauge B is at the angle of 120 degree from x-axis, and here this angle is 120 degree, and here this angle is also 120 degree. So here for epsilon n is equal to epsilon A, theta is equal to 0, right? For epsilon n is equal to epsilon B, value of theta is equal to 120 degree, right? Because here from x-axis, theta in anticlockwise direction is having value 120 degree. And for epsilon n is equal to epsilon C, what will be the value of theta? For that, you have to take angle from x-axis in anticlockwise direction. Means here we have to take this angle. And this angle will be 120 plus 120, that is equal to 240 degree. Fine. So now from this you can find out three equations by using same method as discussed earlier, and you can also find epsilon x, epsilon y and gamma x y. Fine. So for this case I am not solving it here, you can do it by yourself. Fine. And I hope that it is clear to you that how to solve questions of strain rosette. Fine. Now this is the last topic of this chapter, that is stress tensor. Now this stress tensor is used to define state of stress at any point. Means we can represent state of stress at any point in the body by stress tensor. And here you can see that this is the stress tensor for this loading condition shown in this figure. In the figure you can see that we have this type of cube, and here this is the origin, that is point 0, 0, 0. Here this axis is x-axis, this axis is y-axis, and this axis is z-axis. Now here this body is having 3D loading condition in the body. Fine. And here on this plane, which is plane perpendicular to the x-axis, is called as x-plane, on which there are three stresses. One is normal stress, that is sigma xx, and two shear stress, one in y direction and one in z direction. Here in the tau yx, this x shows the plane, that is x plane, and this y shows direction of this shear stress. Means here this tau yx is stress in y direction on x plane. Fine. And you can understand that this tau zx is shear stress in z direction on plane x. Fine. And this is the normal stress, that is sigma xs, which is in x direction on plane x. So here in this body, this first alphabet shows the direction of stress in the body, and this second alphabet shows plane on which stress is applied. Here plane perpendicular to the x-axis is called as x-plane. This plane which is perpendicular to the y-axis is called as y-plane. And this plane which is perpendicular to the z-axis is called as z-plane. Fine. And now you can understand that this sigma yy means normal strain in y direction on y plane of this body. And here in this figure, this sigma is normal stress and this tau is shear stress. Fine. Now here this tau xy means this shear stress is in the x direction on y plane, and this tau zy shows that this shear stress is in the z direction on y plane, and it is similar for z plane. Here this sigma zz shows normal stress in z direction on z plane. This tau yz shows shear stress in y direction on z plane, and this tau xz shows shear stress in x direction on z plane. Fine. And now we can represent this all the stresses applied on this body by stress tensor. here you can see that this stress tensor is denoted by sigma ij, and here these three stresses are on the x plane, these three stresses are on the y plane, and these three stresses are on the z plane. Means here there are planes, and here you can see that these three stresses are in the x direction, these three stresses are in the y direction, and these three stresses are in the z direction. Means this shows the direction. So if stress tensor is given to you, then you can understand loading condition in the body. Fine? And here this stress tensor is for the 3D loading condition. For 2D loading condition, stress in z direction and stress on z plane is 0. Means here these three values are 0 and these two values are also 0. So for 2D loading condition, this stress tensor can be written as sigma xx tau xy. Here there is tau yx and here there is sigma yy. And we can also write these values as 0. Or we can also write that sigma ij is equal to sigma xx tau xy tau yx and sigma yy. So here this stress tensor is for 2D loading condition. Fine? And also remember that for equilibrium, tau xy is equal to tau yx, tau yz is equal to tau zy, and tau xz is equal to tau zx in this body. So actually this term and this term is same. Similarly, these both terms are same and these both terms are same. So here this matrix is having symmetry value about this diagonal, so we can say that this stress tensor is a symmetric matrix. Fine? So actually to define state of stress in 3D loading condition, you require these 6 components. If you have these 6 components, then you will also have these 3 components. Fine? So we can say that to define state of stress in 3D loading condition at any point, you require 6 components of different stresses. Fine? And similarly, for 2D loading condition, here these both terms are same. So in 2D loading condition, you require these 3 components of stresses to define stress in any point of body which is under 2D loading condition. Fine? So I hope that now you have basic idea about stress tensor. Fine? So here our chapter 7 is completed. From this chapter you have to remember lots of formulas, and once you will remember that formulas, it will be easy to solve question from this chapter. Fine? So we will stop here and we will continue in the next video. Till then, stay motivated and happy practicing.